Alrighty, so this section is talking about exponential growth and decay. Please take a look at your announcements. Make sure that you know when your deadlines are, your due dates, your quizzes, etc. So far we learned about this equation for exponentials, right? When this b value is greater than 1, you experience growth, right? Which is what makes the graph look like this, a ski slope that increases. And if b was less than 1, the graph would look like this, it decreases. That's called exponential decay. Now, sometimes we'll get things that give us percentages. And so when we see a percentage, we have to use a different formula. So the formula looks like this, okay? A is still the initial amount. But in this case, they break up the b value into 1 and then either plus r or minus r, where r is called the growth or decay rate. Rates, remember, are percentages, so you have to convert them to a decimal. Okay, so these things will be some kind of decimal. So 1 plus a decimal or 1 minus a decimal, depending on if it's growth or decay. So all that we're going to do for this part is we're going to identify if the following functions are growth or decay. Okay, so that's just looking at this b value. Pick a new color. So here my b value is 0.75. So because that's less than 1, that'll be decay. Here my b value is 3. That's bigger than 1, so that's a growth. Here, 1/2 is less than 1. That would be decay. Here, the 2 is greater than 1, so that would be growth. 5/2, this one's kind of tricky, right, because it's a fraction. But 5/2 is bigger than 1, so this one's actually a growth. You could also see it as a decimal, right? So this is clearly bigger than 1, it's 1.4, which is also growth. So notice, we didn't care about the a value, the initial value at all, those didn't matter. The only thing that told you growth or decay was your b value. So now what we're going to do is we're going to practice with this. So this one wants us to write an equation with an initial value of 100. So that means that a equals 100 here. And a decay factor of 95%. Okay, so when it says decay factor, okay, we're going to use this formula, okay? So B is the growth or decay factor, okay? If it talks about a rate, it's this one on the right. If it's a factor, it's on the left, okay? So that means that B here is the 95%, which to write as a decimal would be 0.95. So our equation would say f of x equals 100 times 0.95 to the x power. Okay, this next one. The foundation of your house has about 1,200 termites. Write an equation that models the number of termites that grow at a rate of 2.4% per year. So when you see a rate, that's R. So 2.4, I'm going to move the decimal over twice. So that would be 0.024. Also, it's worth mentioning that it's growing. So when I write my equation, I'm going to say f of x equals 1,200 times 1 plus 0.024 to the x. Now when we use this form of the equation, we have to go ahead and actually combine those parentheses. So when I add the 1 plus 0.024, I get 1.024 to the x. All right, let's do it again. So the population of Albuquerque is 560,000. And it grows at a rate, okay, we need the word grows. The word rate tells us we're using the right-hand formula. a point, or 1.26 annually. So we move the decimal over twice, and that's our rate. So I'm going to write out the equation, right? So I say f of x equals 560,000. Ooh, I'm going to run into my other box. Let me scoot this over. Sorry about that, guys. And it's growing, right? So I'm adding the 0.0126. So as we learned earlier, you can't combine the 560,000 and this b value because this one has an exponent and this one doesn't, okay? Also, don't lose the exponent. A lot of kids forget that. All right, so this one says a new car costs $23,000, so that's your initial amount. And its value depreciates. So to depreciate is to decrease by 15% each year. So do you notice how it's not using the word rate? That's a little scary. But it is still a rate here, okay? When it says it depreciates by 15%, it means it's taking away 15%. So that would be r equals negative 0.15. So now I write this out, right? So I have f of x equals the initial value, 23,000. And then times 1 minus 0.15 to the x. And again, you want to combine that rate together with the 1. I'm just wanting to write those zeros there. There we go. So in this case, it would be 0.85 to the x. And so because that b value is less than 1, that's what causes it to depreciate, right? It cuts down. Kids tend to mess up on this type of question because they put the 0.15 here and they forget the 1. But you have to have both pieces in here to make this value. So now what we're doing is we're reading a word problem, and now we're actually going to find the value. We're going to do the calculation for it. So an investment of $75,000, right? That's your A value, right? Increases, so it's positive, at a rate of 12.5%. So that means that your R is 0.125 per year. Find the value in the investment after 30 years. So that's my X value. So when I do this, the equation that I'm writing is I'm putting 75,000 in the A position. And I'm growing at a rate here, right? So I'm adding the 12.5% per year. So this is the equation I'm going to use. And now I'm plugging the 30 into the equation. I'm also combining my like terms there, just while I'm at it. So this part, okay, I'm going to have to use Desmos in order to do. Okay, so when I go to do this calculation, if I'm using like a normal hand calculator, I would raise to this exponent and then times it by the 75,000, okay? I'm going to try it on Desmos. I don't know if my recording will pull up Desmos for you guys, but I'm certainly hopeful. All right, so Desmos, you could just kind of type it in as you see it. So I typed in 75,000, putting in some parentheses, 1.125, and then I'm using the A to the B button in order to type the number 30 in there. And so when I did that, my Desmos gave me a really long number. Okay, now remember, this is money, so it has to go to 2 decimal places. Oops, need my pen to write. So I got 2568247.87, and it says 126 after that. And so the 1 would make it stay at a 7 here. Now we're going to add some commas so that it's easy to understand what kind of money it is. A little dollar sign on there. And so there's our investment after 30 years. $2.5 million, that's not too bad, eh? All right, so let's look at this one. So a computer is valued at $6,500, so that's the initial amount. And it's depreciating at a rate of 14.3% per year. Okay, so depreciating means that our rate here is negative, right? So 14.3, I'm writing as 0.143. And they want us to figure out after 3 years. So my equation, I'm going to put the 6,500 in where the A is, that initial amount. I have 1 minus 0.143 because of the depreciation. So in this case, right, oh, I lost my 5. Don't be a silly goose like Miss Caswell. Okay. And then I'm going to use my calculator because I don't know what 1 minus 0.143 is. Some kids, they tend to lose that decimal place. Don't make any silly goose mistakes there. Like, be very clear that you have a decimal there. Okay, and so now I'm going to find that to the third power. So I'm finding this equation. And where x is, I'm replacing it with a 3. Okay, I'm just going to do that on my calculator that's off screen. Just so that I'm not tabbing through and confusing people while I write. So when I go to do my calculator, oops, I need to replace the 3 into the equation, don't I? Boop, boop. Because you can't actually find it unless you have all the numbers filled in, right? So in my calculator, I'm doing this piece. I'm raising it to the exponent of 3. And now I'm timesing in the 6,500. So when I do that, I get $4,091, and it says 248, but the 8 will cause this to round up to 25. 2 more. Okay, so East High School has seen a decrease in the student population. So that word decrease is telling you your rate here is negative, right? At the beginning of this school year, they had 2,400 students, so that's our initial amount. And the population has been decreasing at an annual rate of 2%. So 2% is 0.02. And it wants to know the population after 5 years. So our equation, again, that's a rate, an annual rate that it's decreasing by. So I'm using this equation that has the 1 plus or 1 minus on it. So when I kind of clean up that parenthesis, right, I have 0.98 here that I'm raising to the x. Then to find after 5 years, now I'm replacing the 5 into the equation for x and solving it. So once again, when I go to solve it, I'm going to start by taking the 0.98 and I'm going to raise it to the 5th power. And different calculators have different buttons to raise that exponent. So make sure you know in your calculator what button to hit. And once I have that number, which is really ugly, I don't clear it out, I keep it, and I just times that by 2,400. So in this case, I have 2,169. Now these are people, right? These are human beings, so I'm not going to have any weird decimals on that because you can't have part of a person unless you're a serial killer. Okay? And it was 0.4, so this is going to stay at 69. Now let's look at this one. This problem's a little bit different. Look at the phrasing on it because that's what's going to mess us up. So Nancy opens a ransomware email on her work computer. So in terms of initial amount, that's just her, right? One computer was the initial amount. Nancy. So every hour, it emails 5 other people. So that's not like a rate, right? That's not a percentage. Okay? So what that means is that 5 other people is our B value. Okay? So we're going to plug it in, right? So I have f of x equals 1 times 5 to the x. So if I'm finding f of 4, I have 5 to the 4th power, which when you put that in a calculator is 625. So after 4 hours, 625 people would be infected, which is wild with how that virus spreads. So there we have it.